Hi guys, this is Manohar and welcome to Tutoralz. Today in this video, we are going to discuss about the topic new vessel in the alligation and mixture. Okay, actually this is the fifth part of alligation and mixture. If you haven't watched the previous parts, I recommend you to please watch previous parts of the alligation and mixture so that you can come to know what is the concept of alligation and mixture and also what are the methods we use to solve the problems. Okay, now in this video, we are going to discuss about the topic new vessel in the alligation and mixture. Okay, new vessel is nothing but adding two quantities of mixtures into a new vessel and mixing them. Okay, adding two quantities of mixtures into a new vessel and mixing them. Okay, now I will take one example so that you can understand what is this new vessel concept is. See here, suppose I have one quantity of mixture that contains milk is to water in the ratio of 2:3. Okay, and also I have another quantity of mixture that contains milk is to water in the ratio 3:2. Okay, now I need to mix these both the quantities and pour to a new vessel. Okay, now what is the ratio of milk and water in that new vessel? This is the concept behind this new vessel in the alligation and mixture. Okay, in new vessel concept we will add two or more quantities and mix them into a single vessel. Okay, now in this video I will tell you what is the concept behind it and also I will tell you what are the methods we use to solve the problems in this kind of new vessel problems. Okay, now first of all I will take one example and show you what are the methods we use. Okay, and then we can move to the some basic level problems. Okay, now consider the same example, that is in one vessel. Okay, in one vessel there is a milk is to water ratio of 2:3. Okay, in the same way there is another vessel. Okay, now the milk is to water ratio is in the 3:2. Okay, now I need to mix these both the quantities. Okay, and find out what is the ratio of milk is to water in the resultant quantity. Okay, now to solve this kind of problems we usually use two methods. Okay, one is normal method or basic method. Okay, one is normal or basic method and another one is units or parts method. Okay, now I will show you both the methods and also you can understand how to use these two methods to solve the problems. Okay, now first let us see what is the normal method. See here, in normal method, to find out what is the resultant quantity ratio, we will write all the quantities of milk on one side and all the quantities of water on the other side. Okay, see here, first of all in the first mixture, the ratio of milk, that is there are totally 2 plus 3, there are totally 5 parts in the first mixture. Okay, in the second mixture there are totally 3 plus 2, 5 parts. Okay, now we will write all the quantities of milk on the left side and all the quantities of water on the right side. Okay, now see here, out of 5 parts, what is the part of milk? That is only 2 parts, right? Out of 5 parts, milk quantity is 2 parts. Now what is the quantity of milk in the other vessel? That is out of 5 parts, milk ratio is 3 parts. Okay, now out of 5 parts, milk ratio is 3 parts. Now we have wrote all the quantities of milk on the left hand side. Okay, now on the right hand side we will write all the quantities of water. Okay, see here, out of 5 parts in the first vessel the quantity of water is 3 parts. Okay, now in the second vessel out of 5 parts the quantity of water is 2 parts. Okay, now we have wrote all the milk quantities on the left hand side and all the water quantities on the right hand side. Okay, see here, now if I cancel this I will get the LCM will be 5, 2 plus 3, that is 5 by 5 is to the LCM will be 5 and 3 plus 2, 5. So I will get 1:1 ratio. So if I mix these two quantities into a new vessel, I will get the ratio of milk is to water in the 1:1. Okay, now let's see how to solve the same problem using this units or parts method. See here, in units or parts method, we will count what are the number of parts in both the vessels. Okay, see here, in the first quantity, that is in the first mixture, the ratio is milk is to water, the ratio is 2:3, right? In the second vessel, the ratio is 3:2. Now, in order to mix these two quantities, the number of parts in the both vessels needs to be same. Okay, see here, the number of parts in the first vessel, that is 2 plus 3, there are totally 5 parts. Okay, here also 3 plus 2, there are totally 5 parts. Okay, now if both the parts are equal, we can directly add them. So 3 plus 2, 5 is to 2 plus 3, 5. So there are totally, the ratio is 1:1 in the new vessel. Okay, in the units or parts method, we will count what are the total number of parts in the both vessels. Okay, if both vessels, the quantities are same, that is parts are same, we will directly add the total quantity so that we can get what is the ratio of milk and water in the new vessel. Okay, now you can ask me what if the parts are different. Okay, now I will show you what if the parts are different. See here, suppose assume that the second vessel contains, second vessel contains milk is to water in the ratio of 2 is to 5. Okay, suppose assume that first vessel is 2 is to 3 and second vessel is 2 is to 5. Now see here, if the parts are different, see here, milk is to water, okay. Now in the first vessel, 2 is to 3. In the second vessel, 2 is to 5. Okay. Now see here, in the first vessel, the total parts, that is 2 plus 3, there are totally 5 parts. Okay. In the second vessel, 5 plus 2, there are totally 7 parts. Okay. Now here, the total parts are different in first vessel and second vessel. So we can't directly add them. Okay. Now we need to equate the both parts. Okay. How can we equate them? See here, the total parts in the first vessel is 5 parts and second vessel is 7 parts. So these are not equal. We need to make these parts as equal in both first and second vessel. So now how can we equate them? See here, by taking LCM of total parts, that is the LCM of 5 and 7. The LCM of 5 and 7 is 35. Okay. Now to make this total 5 parts as 35, I need to multiply entire ratio with 7. Okay. Now in order to make this total parts as 35, I need to multiply the second ratio with 5. Okay. Now we will get, see here, if you multiply by 7, I will get 7 2's 14, 7 3's 21. Okay. Now 5 2's 10, 5 5's 25. Now see here, 14 plus 21, there are totally 35 parts in the first vessel. Okay. And also in the second vessel, 25 plus 10, there are totally 35 parts in the second vessel. Now the both first and second vessel, the parts are equal. So we can directly add them. So we will get 21 plus 25, that is 46, and 10 plus 14, that is 24. So the ratio is 24 is to 46. So if I cancel this, I will get 4, okay, 2 12's 24 and 2 23's. So the ratio is 12 is to 23. Okay. In this way, we will solve the units or parts method. See here, in the normal method, whether the quantities are same or not, the method will be same. Okay, there will be no change in the method we follow. But in units or parts method, the quantities of two vessels needs to be same. That is, the total parts in the first and second vessel needs to be same. Okay, if they are not same, we will make equal parts by taking LCM of total parts. Okay, now I have made the same method here. Okay, now you can ask me which method is very easy. See here, I will always suggest you to go through units or parts method, because whenever the quantities are same here, we can directly add them and we can say the answer is 1:1. Okay, but in the normal method, we need to do all the calculations to get the ratio 1:1. Okay, even though the parts are different, we can directly take LCM and we can directly equate them and tell what is the final ratio. Okay, but in normal method, no matter whether the parts are equal or not, we need to do all this calculation. That's the reason I will always suggest you to follow units or parts method from the beginning itself, because through this method we can solve the problem within very fraction of seconds. Okay, suppose assume that this is the question only. Okay, suppose assume that this is the same question given in the exams. You can directly say by adding the both ratios, the answer is 1:1. Okay, within fraction of seconds. It takes almost 5 to 10 seconds to say the answer. Okay, 2 plus 3 is 5 and 2 plus 3 is 5, 1:1. Okay, in this way we can calculate very faster way to find out what is the final ratio. Okay, that's the reason always try to follow units or parts method to calculate faster. But also learn what is normal method, because this is the exact concept behind the new vessel. Okay, this is the exact concept, but it will take some more calculations to find the answer. But units or parts method, we can do it very faster way. Okay, the both methods are fine. Try to learn both methods and try to follow units or parts method from the beginning itself. Okay. Now I will explain you the both methods once again. Try to understand this very clearly, because the new vessel concept in this alligation and mixture is very easy and you can gain marks very quickly when it is given in the problems. Okay, when it is given in the exams based on this new vessel concept, you can gain the marks very quickly. Okay, that's the reason try to understand both methods very clearly so that you can solve the problem within very fraction of seconds. Okay, now the only in normal method, the only difference is we will write all the quantities of first quantity in the left hand side and all the ratios of second quantity on the right hand side. Okay, here also we wrote all the quantities of milk on the left hand side and all quantities of water on the right hand side. Okay, then we can simply calculate them and find the total ratio. Okay, and when it comes to units or parts method, we will find out what is the total number of parts in the first and second vessel. Okay, if total parts are same in both the vessels, we will directly add the ratios and find out what is the resultant ratio. Okay, if total parts are different, we will take LCM of first and second vessel parts, then we can equate the total parts in the both vessels. Okay, after equating, we will simply add the ratios and find out what is the resultant ratio. Okay, and this is the only difference between these units and also normal method. And let's solve some basic level problems so that you can understand how to use these two methods to solve the problems. Okay, now let's see the first problem. They are saying that there are two containers of equal capacity. The ratio of milk to water in the first container is 3:1 and in the second container is 5:2. If they are mixed up, then the ratio of milk to water in the mixture is. So we need to find out what is the ratio of milk to water in the resultant mixture. Okay, now let's see the problem. See here, in the first container, the milk to water ratio is 3:1. Okay, and in the second container, milk to water ratio is 5:2. Okay, now we need to find out what is the total ratio of milk to water in the resultant quantity. Okay, see here I have already told you in the normal method we need to write all the milk quantities on the left hand side and all the water quantities on the right hand side. Okay, now let's see this. Out of four parts, milk quantity is 3 parts in the first vessel. Okay, and in the second vessel, out of 7 parts, milk quantity is only 5 parts. Okay, is to the water quantities are out of 4 parts, water quantity is only 1 part, plus out of 7 parts, the water quantity is 2 parts. Okay, now if I solve this, I will get what is the total ratio of milk to water in the resultant quantity. Okay, see this, the LCM of 7 and 4 is 28. Okay, now 3 by 4 into 28, that is 4 7s 28 and 7 3s 21, plus 5 by 7 into 28, that is 7 4s 28 and 5 4s 20, is to the LCM will be 4 and 7, that is 28, and 1 by 4 into 28, that is 4 7s 28, plus 2 by 7 into 28, that is 7 4s 28 and 2 4s 8. So the 28 and 28 will be cancelled and we will get 21 plus 20, that is 41, is to 7 plus 8, that is 15. So the ratio of milk to water in the resultant quantity is 41:15. Okay, now let's solve the same problem using this units and parts method. See here, in the first vessel, the milk and water ratio is 3:1. And in the second vessel, the milk and water ratio is 5:2. Okay, now we need to find what is the total number of parts in the first and second vessel. Okay, I have already told you we can add the total ratios only if the total parts are equal. Okay, if parts are not equal, we need to equate them. Okay, now let's see this. The total number of parts in the first vessel is 3 plus 1, that is 4 parts, and in the second vessel is 5 plus 2, that is 7 parts. Okay, here the parts are not equal, so we can't directly add the total ratios. Okay, now we need to equate the two total parts of the first and second vessel. Okay, now how can we equate them? By taking LCM of total parts of first and second vessel. That is the LCM of 7 and 4, that is 28 units. Okay, now to make this first part as 28, I need to multiply all the ratio into 7 and I need to multiply all the ratio of second vessel into 4. Okay, now I will get the resultant ratio is 7:3, that is 21 is to 7 into 1, that is 7. Okay, now 4 into 5, that is 20 and 4 to 8. So I will get 21 plus 7, here 28 and 20 plus 8, that is 28. So here the total number of parts in the resultant quantity is same here. Okay, now we can directly add the total ratios. So we will get 20 plus 21, that is 41 is to 8 plus 7, that is 15. The ratio is 41:15 in the resultant mixture. Okay, in this way we will solve the normal and also units or parts method. Okay, now let's see the second problem. They are saying that 2 equal parts of milk and water are mixed together in the ratio of 7:6. If the ratio of milk and water in the first part was 4:1 and the ratio of milk and water in the second part was 2:3, then find out by how much percentage the quantity of milk was more than water in the final mixture. So we need to find out by how much percentage milk was greater than water in the final mixture. Okay, in the previous problems it is not given in what ratio these two quantities need to be mixed. Okay, but here it is clearly given that in the what ratio these two quantities are need to be mixed, that is 7:6. Okay, these two quantities mixed in the ratio of 7:6. Now let's see how to solve the problem. See here, in the first vessel milk and water ratio, that is 4:1. Okay, and in the second vessel, milk and water ratio is 2:3. Okay, now what they are saying is these two quantities are mixed in the ratio of 7:6. Okay, in the sense, in the resultant quantity, all the first vessel is mixed by 7 parts and all the second vessel mixed by 6 parts. Okay, in the resultant quantity, all the first vessel quantities are mixed by 7 parts and all the second vessel quantities mixed by 6 parts. Okay, now see here how to solve the problem. I have already told you in the normal method, all the left side quantities will be written on the left hand side and all the right side quantities written on the right hand side. See here, out of 5 parts, water that is milk quantity is, out of 5 parts, milk quantity is 4 parts. Since it belongs to first vessel, I am multiplying the milk quantity into 7. Okay, see here, the first vessel need to be in the parts of 7 parts in the resultant quantity, right? So, since milk is belongs to first vessel, I am multiplying milk quantity into 7. Okay, in the same way, I am multiplying milk, that is out of 5 parts, milk part is 2 parts. Since it is belongs to second vessel, I am multiplying this by 6. Okay, in the same way, water quantity, that is out of 5 parts, water quantity is only 1 part and it belongs to first vessel. So, I am multiplying with 7. Okay, plus water quantity, that is out of 5 parts, water quantity is 3 parts. Since it belongs to second vessel, I am multiplying into 6. Okay, I hope you are understanding. See here, all the first vessel need to be in the parts of 7 parts. Okay, all the second vessel need to be mixed by 6 parts. So, since these quantities are belongs to first and second vessel, I am multiplying all the quantities of first vessel by 7 and all the quantities of second vessel by 6. Okay, now if I solve this, I will get what is the ratio. Okay, see here, so we can directly take LCM here, that is 5. Okay, so 4 7s 28 plus 2 6 12 is to, the LCM will be 5 and 7 plus 3 6 18. Okay, so we can cancel 5 and 5 here, so we will get 28 plus 12, that is 40 is to 7 plus 18, that is 25. Now they are saying that what is the percentage, that is by how much percentage this milk is greater than water in the final mixture. Okay, suppose assume that this 25 parts has 100%. Okay, suppose assume that the quantity of water, that is 25 parts has 100%. Now what is the 40 parts, that is 40 parts equal to 40 into 100 by 25. So we will get 25 ones, 25 fours, that is 40 fours 160. Okay, I am assuming the quantity of water as 100%. So what is the percentage of milk, that is 160%. So 160% minus 100%, that is 60% more water than water. Sorry, 60% more milk than water. Okay, see here I am assuming the quantity of water as 100%. Okay, we need to find out by how much percentage milk is greater than water. Okay, see here, since I am assuming 25 parts as 100%, what is the value of 40 parts? Okay, 40 parts value will be 160%. Okay, now we have already know 25 parts value is 100%. Now how much greater it is? 60% greater than water. Okay, so in the resultant quantity, the milk quantity is only 60% greater than water. Okay, now let's see how to solve the same problem in the units or parts method. See here, in the first vessel, it is given the ratio is milk and water, ratio is 4:1. Okay, and in the second vessel, the ratio is 2:3. Now let's see how many parts are there in the first and second vessel. Okay, in the first vessel, total parts, that is 4 plus 1, 5 parts, and in the second vessel, there are totally 2 plus 3, 5 parts. Okay, now they are saying that these two vessels need to be mixed in the ratio of 7:6. In the sense, all the first vessel need to be mixed by 7 parts and all the second vessel need to be mixed by 6 parts. Okay, here the both parts are equal, already equal, so we don't want to equate them. Okay, now we have to mix the total first vessel by 7 parts and total second vessel by 6 parts. So I am multiplying all the first vessel by 7 and all the second vessel by 6. Okay, see here I will get 7 fours 28 is to 7 1 7. 6 2 12 plus is to 6 3 18. So I will get 28 plus 12, that is 40 is to 7 plus 18, that is 25. Now they are asking us to find out by how much percentage milk is greater than the water. See here, if 25 parts equal to 100%, now what is the value of 40 parts? So we will get 40 into 100 by 25. 25 ones, 25 fours, 40 fours, 160. So milk is 60% more than water in the final mixture. Okay, I hope you are understanding. See here, the only difference between the before question and also this question is, here they have given the two quantities need to be mixed in the ratio of 7:6. Okay, since they have given the 7:6, I am multiplying all the first vessel quantities by 7 and all the second vessel quantities by 6. Okay, here also I am doing the same. Okay, here we are already, the total parts are same in both the vessels, that is first and second vessel. Okay, as the other reason I am directly multiplying both the ratios by 7 and 6 and I am getting the ratio as 40:25. Okay, if the both parts are not equal, then first we can equate them and then we can multiply by 7 and 6. Okay, since they are equal, I am directly multiplying with 7 and 6 and finding what is the ratio. Okay, now let's see the third problem. They are saying that if 2 kg of metal of which 1/3 is zinc and the rest is copper be mixed with 3 kg of metal of which 1/4 is zinc and the rest is copper, what is the ratio of zinc to copper in the mixture? So we need to find out what is the final ratio of zinc to copper in the resultant mixture. Okay, this is also the same kind of problem that we solved earlier, that is second problem. See here, they are saying that, okay, first metal and second metal. Okay, now the ratio of zinc to copper and the ratio of zinc to copper. So they are saying that in the first metal, the quantity of zinc is 1/3. Okay, 1/3. So what is the resultant remaining quantity? That is 1 minus 1/3 equal to 2/3. So 2/3 quantity will be belongs to copper. Okay, here they are saying that the quantity of zinc in the first metal is only 1/3 part. So what is the part remaining? That is 2/3 part is remaining. So 2/3 will be belongs to copper ratio. Okay, now in the same way in the second metal they are saying that the quantity of zinc is 1/4. Okay, now what is the quantity remaining? That is 1 minus 1/4. So we will get 3/4. Okay, now if I cancel this, 3 and 3 will be cancelled and 4 and 4 will be cancelled. Now we will get 1:2 and 1:3. Okay, now what they are saying is the entire quantity is mixed in the form of first metal is mixed with 2 kgs of first metal and 3 kgs of second metal. Okay, so they are mixing 2 kgs of first metal and 3 kgs of second metal. Okay, now we will multiply all the first metal quantities with 2 and all the second metal quantities with 3 because they are mixing 2 kgs of first metal and 3 kgs of second metal. Okay, see here, all the first metal quantities, that is out of 3 parts the zinc quantity is out of 3 parts the only 1 part. So since it belongs to first metal, I am multiplying it with 2. Okay, in the same way, what is the quantity of zinc in the second metal? That is out of 4 parts the quantity of zinc is only 1 part. Since it belongs to second metal, I am multiplying it by 3. Okay, now see here, in the same way I will write copper also. Out of 3 parts the quantity of copper is 2 parts into, since it belongs to first metal, I am multiplying it by 2. Okay, and also in the second metal, out of 4 parts the quantity of copper is 3 parts. Since it belongs to second metal, I am multiplying it by 3. Okay, whatever the quantities belongs to first metal, I am multiplying it by 2 and whatever the quantities belongs to second metal, I am multiplying it by 3. Okay, now if I solve this, I will get the final ratio. Okay, see here, the LCM will be 4 and 3, that is 12, and 1/3 into 12, that is 1/3 into 12, 3 4s 12 and 4 2s 8. 8 plus 1/4 into 12, that 4 3s 12 and 3 3s 9 is 2. The LCM will be 12 and 3 4s 12 and 2 2s 4, 4 4s 16 plus 3/4 into 12, that is 4 3s 12 and 3 3s 9, 9 3s 27. So I will get, if I cancel this 12 and 12, I will get 8 plus 9, that is 17 is to 16 plus 27, that is 20 plus 16 will be 36 and 43. Okay, so the final ratio will be 17:43. Okay, the final ratio of zinc to copper is 17:43. Now let's solve the same problem using this units or parts method. See here, the ratio of zinc to copper. Okay, see here, the ratio of zinc to copper in the first metal is 1:2. Okay, I am directly writing the ratio instead of doing this all calculations. Okay, see here, in the second metal, the ratio of zinc to copper is 1:3. Okay, now let's check whether the total parts of first and second metal are same or not. See here, in the first metal, the total number of parts is 2 plus 1, that is 3 parts, and in the second metal, the total number of parts is 3 plus 1, that is 4 parts. Okay, so the total number of parts are different in first and second metal. Okay, so we can't directly add the first and second ratio. So in order to add first and second ratio, first of all we need to equate total number of parts in the first and second metal. Okay, in order to make it equal, I need to take the LCM of first and second part, that is the LCM of 3 and 4, that is 12 units. Okay, now to make this first ratio as 12 parts, I need to multiply whole ratio with 4. Okay, in order to make the second part as 12 units, I need to multiply whole ratio with 3. Okay, see here the LCM is 12 units. So in order to make first metal as 12 parts, I need to multiply all ratio of first metal into 4. Okay, in order to make second ratio as 12 parts, I need to multiply whole ratio with 3. So we will get 4 ones 4, 4 2s 8, and 3 ones 3, 3 3s 9. Now let's check whether the total parts are same or not. Okay, 8 plus 4, that is 12 parts. In the below also 9 plus 3, that is 12 parts. So the total number of parts in first and second metal are same. Okay, now what they are saying is first metal is mixed with 2 kgs of matter, and also second metal is mixed with 3 kgs. Okay, first metal is mixed with 2 kgs. Okay, that is 2 kgs of first metal and 3 kgs of second metal need to be mixed to get a final mixture. Okay, 2 kgs of first metal and 3 kgs of second metal. Okay, so since it is 2 kgs, I am multiplying whole ratio with 2. Okay, since it is 3 kgs, I am multiplying whole ratio with 3. Okay, now I will get 4 2s 8 and 8 2s 16. 3 3s 9 and 9 3s 27. So I will get 9 plus 8, that is 17, 27 plus 16, that is 43, right? So the total ratio is 17:43. Okay, this is the final ratio of zinc to copper. Okay, see here the only difference is they are giving number of kgs of quantities needs to be mixed. Okay, here 2 kgs of first quantity and 3 kgs of second quantity. If it is not given, we can directly add the total ratios. Okay, but since it is given, we are multiplying first ratio with 2 and second ratio with 3. Okay, that's the reason we are multiplying and also getting final ratio as 17:43. Okay, now let's see the fourth problem. They are saying that a mixture contains wine and water in the ratio of 3:2 and another mixture contains them in the ratio of 4:5. How many liters of latter must be mixed with 3 liters of former so that the resultant mixture may contain equal quantities of wine and water? So we need to find out how many liters of second vessel need to be mixed with 3 liters of first vessel. Okay, see here, in the first vessel wine and water ratio is 3:2 and in the second vessel the wine and water ratio is 4:5. Now what they are saying is how many liters of second vessel need to be mixed with 3 liters of first vessel so that in the resultant quantity wine and water will be equal. Okay, I don't know how many liters of second vessel, so I am assuming the second vessel as x liters. Okay, now x liters of second vessel need to be mixed with 3 liters of first vessel. Okay, now I will multiply all the first vessel quantities with 3 and all the second vessel quantities into x. Okay, in the normal method I will multiply all the first vessel quantities into 3 and all the second vessel quantities into x, because first vessel is 3 liters, second vessel is x liters. Okay, see here, out of 5 parts, the wine quantity is 3 parts. So since it belongs to first vessel, I am multiplying it by 3. Plus out of 9 parts, the wine quantity is 4 parts. Since it belongs to second vessel, I am multiplying it by x. Okay, in the same way for the water also, see here, out of 5 parts, water quantity is 2 parts into 3 plus out of 9 parts, the water quantity is 5 parts into x. So if I solve this, I will get what is the total ratio. Okay, now see here, the LCM of 9 and 5, that is 45 and 5 9s 45 and 3 3s 9, 9 9s 81. 81 plus 9 5s 45, so 4 5s 20, 20x is to, then the LCM will be 45 again here, 9 and 5, okay, 45. So I will get 2 by 5 into 45, that is 5 9s 45, 2 3s 6 and 9 6 54. 54 plus 9 5s 45 and 5 5s 25, 25x. So here 45 and 45 will be cancelled, and what they are saying is in the resultant quantity the both wine and water is same. Okay, the resultant quantity contains the value of both wine and water will be equal. So we can simply equate them. Okay, see here, what they are saying is if x liters of second vessel is mixed with 3 liters of first vessel, in the resultant quantity wine and water will be equal. So we can simply equate the both ratios of wine and water. Okay, now what we will get is 81 plus 20x equal to 54 plus 25x. Okay, sorry, 5 first 25, right? 5 first, yeah. So if I send this 20x to the right hand side and 54 to the left hand side, I will get 81 minus 54 equal to 5x, that is 25 minus 20x. So I will get 81 minus 54, that is 7 and 27. 27 equal to 25 minus 20, that is 5x. So x equal to 27 by 5, that is 5 is 25 and point there will be 2, so 5.4. So x equal to 5.4 liters. Okay, so 5.4 liters of second vessel need to be mixed with 3 liters of first vessel. Okay, the answer is 5.4. Here the simple logic is they are saying the quantities of wine and water are equal. So we are simply equating the both ratios. Okay, this is the simple logic here. That's it. Now let's solve the same problem using this units or parts method. See here, the quantity of wine and water. Okay, the ratio of wine and water in the first vessel is 3:2. Okay, and in the second vessel is 4:5. Okay, now let's check whether the total number of parts of first and second vessel are equal or not. See here, in the first vessel the total number of parts, that is 3 plus 2 equal to 5. Okay, and in the second vessel the total number of parts, that is 4 plus 5, that is 9 parts. So the total number of parts in the first and second vessel are not equal. Okay, now how can we equate them? So by taking LCM of 5 and 9, that is 45 units. Okay, now to make this first vessel as 45 parts, I need to multiply first ratio with 9 and also second ratio with 5. So we will get 9 3s 27 is to 9 2s 18, and also 5 4s 20 is to 5 5s 25. Now let's check whether the total number of parts in the first and second vessel are equal or not. See here, 27 plus 18, that is totally 45 parts. Okay, and 20 plus 25, that is totally 45 parts. So the total number of parts in first and second vessel are equal. Okay, now we can directly add the total ratios. But what they are saying is the first vessel contains 3 liters of mixture and we don't know what is the total quantity of second mixture. Okay, see here, they are saying that first vessel contains 3 liters of mixture. Okay, and we don't know how many liters of second vessel. So I am assuming it as x liters. Okay, now if I multiply first ratio with 3 and second ratio with x, I will get 27 into 3, that is 81 is to 18 3 is 54. 54. And in the same way, second ratio, that is 20x is to 25x. So we will get, if I add this both ratios, I will get 81 plus 20x is to 54 plus 25x. Now what they are saying is, in the final quantity, the both wine and water quantities are equal. So we can simply equate the ratios of wine and water. Okay, in the final quantity, the ratios of or quantities of wine and water are equal. So we can simply equate the ratios of wine and water. So we will get 20x plus 81 equal to 54 and 25x. So if I send this 20x to the right hand side and 54 to the left hand side, I will get 81 minus 54 equal to 25 minus 20x. Okay, so I will get 5x equal to 27 and x equal to 5.4 liters. So the second vessel contains 5.4 liters of mixture. Okay, so in this way we will solve the both normal and also units parts method. Okay, now let's look at our fifth problem. They are saying that there are 3 tubs which contain mixtures of milk and water in the ratio of 5:2, 4:3 and 3:1. If the mixtures are poured into a single tub, find the ratio of milk and water. Okay, in the previous problems they have given only 2 vessels, but here it is given 3 vessels. Okay, see here, no matter how many vessels they give, the process will be same. Okay, we will solve the problems in the same methods. Okay, see here, in there are 3 tubs containing a ratio of milk and water, that is 5:2 and 4:3 and 3:1. Okay, see here, I will write all the quantities of left side quantities, that is in the left hand side, and all the quantities of right side in the right hand side. So I will get, out of 7 parts, the quantity of milk is 5 parts, plus out of 7 parts, the quantity of milk is 4 parts. In the same way, out of 4 parts, the quantity of milk is 3 parts. Okay, is to out of 7 parts the quantity of water is 2 parts, plus out of 7 parts the quantity of water is 3 parts, plus out of 4 parts the quantity of water is 1 part. Okay, no matter how many vessels they give, the process will be same. Okay, now if I solve this, I will get final ratio. See here, the LCM of 7 and 4, that is 7 4 28. So the LCM is 28 here. So 5 by 7 into 28, that is 7 4 28, 5 4 20, plus 4 by 7 into 28, that is 7 4 28 and 4 4 16, plus 3 by 4 into 28, that is 4 7 28, 3 7 7 3 21, yeah, 21 is to, okay, now the LCM here also 7 and 4, that is LCM will be same, that is 28. So we will get 2 by 7 into 28, that is 7 4 28, 2 4 8, plus 3 by 7 into 28, that is 7 4 28 and 3 4 12, plus 1 by 4 into 28, that is 4 7 28, so 7 here. Okay, we will get, I will cancel this 28 and 28 here. So we will get 20 plus 16, that is 36, and 36 plus 21, that is 57. Okay, so 57 is to 8 plus 12, that is 20, 20 plus 7, that is 27. So I will get, okay, if I cancel this with 3 9s 27 and 3 1s 3, 3 9s 27. So 19 is to 9. So the final ratio of milk and water in the new vessel is 19 is to 9. Okay, now let's solve the same method, same problem using this units or parts method. See here, the quantities of 3 vessels, that is milk and water. Okay, so 5 is to 2 and 4 is to 3 and 3 is to 1. Okay, now let's check whether the parts of all the 3 vessels are same or not. See here, the total parts of first vessel, that is 5 plus 2 equal to 7 and 4 plus 3 equal to 7 and 3 plus 4, that is 4. So the total number of parts in all the 3 vessels are net same. Okay, so we need to equate all the total parts of first, second and third vessel. So how can we equate them? By taking LCM of all the 3 vessels. Okay, that LCM of 7 7 and 4, that is 28 units. Okay, now to make this first vessel as 28, I need to multiply all vessel with 4. In the same way, second vessel with 4 and third vessel with 7. Okay, now we will get 4 5s 20 is to 4 2s 8. 4 5s 20, 4 3s, sorry, 4 4 16, okay, 4 3s 12, 7 3s 21, 7 1 7. Okay, now let's check whether all the parts are same or not. See here, 20 plus 8, 28, 16 plus 12, that is 28, and 21 plus 7, that is 28. Okay, now all the 3 parts are same in all the 3 vessels. Okay, total number of parts are same in all the 3 vessels. Now we can directly add all the ratios. Okay, so we will get 12 plus 7, that is 19, 19 plus 8, that is 27. Okay, 21 plus 16, that is 37, 37 plus 20, that is 57. So the ratio is 57 is to 27. So if I cancel this, 3 19s 57 and 3 9s 27. So 19 is to 9. So the ratio of new measure is 19 is to 9. Okay, and that's it for this video. Try to solve more and more problems based on this alligation and mixture. Okay, and also always try to use units or parts method from the beginning itself to solve the problems. Okay, the reason why I suggest units or parts method is, using this method you can solve the problems very faster when compared to normal method. Okay, in the normal method we need to take all the LCMs and we need to do all the calculations to find the final answer. Okay, but units or parts method, if you are able to find the LCM, you can simply solve the problem within fraction of seconds. Okay, that's the reason try to solve the problems using units or parts method. Okay, and try to solve more problems so that you can come to know which method is more easier for you. Okay, and if you are unable to solve any problem based on this alligation and mixture, and if you feel any problem is very difficult, you can simply message the problem to us in the Instagram. Okay, so that we can pick the all difficult problems and also we can make a dedicated video for that by solving the problems. Okay, and for more tutorials like this, please subscribe to the channel. Thank you.